Hi there, I'm Jack.
I'm Shayla, and today we're going to talk to you about microencapsulation. And through this presentation, we're going to show you what that is, and then you're going to do a project to make you semi-experts on what microencapsulation is. Before we do that, though, I just wanted to tag on that I am an electrical engineer at Ohio State. I actually worked in a lab and I worked on graphene. So does anyone know what graphene is? Okay, do you know what graphite is? Does anyone know what graphite is? Well, pencil lead, exactly. So graphene is actually the 2D, like the flat structure of a pencil lead is. And what I had to do was make a growth process to make graphene, and that's kind of like making a recipe for cupcakes or cakes. And then so when you bake, you have to control things like temperature, ingredients, and this is just a sample of what I started with. It's just plain nickel, and then it ends up with some graphene on top, and it's kind of spotty. So there are a lot of opportunities at Ohio State to do research, and so Jack, he did a different type of research. He's going to tell you about that.
Right, I'm a chemical engineer. So chemical engineers mostly apply chemistry to the real world. Chemical engineering can also be really relevant to biology. Biology is the study of life, and that's what I try and focus on. I'm really interested in life. So I worked with a professor named Dr. He in the biomedical engineering department last summer on some research. Dr. He has a lab called He Lab.
And in He Lab, if you notice, there were some familiar technologies. So on the right, does anyone know what that is?
Syringe.
So we have a syringe and a microscope. The syringe doctors use to give you shots and things, but in the lab it was used to transport fluids from one place to another. And the microscope was used to see really small things. And
We also had some stuff that was a lot less familiar to me. So in my research, I dealt with a big oven that cooked with pressure and it could cool things down and heat things up really quickly. So that was interesting. And then there was also something called a plasma cleaner that could deal with changing surface properties of different materials using light. So both these were something I'd never seen before, but that were really interesting to me. My actual place in the lab was working with these things that we called PDMS devices, and they're just little gels that had tubes running all through them. And this is how we do microencapsulation. We're going to get to what that is in a second. But it happened all in here, all in these tiny little tubes. And we had input and output channels that we could put things in, get things out, and that's how microencapsulation happened. Shayla, can you tell us what microencapsulation actually is?
okay, so does any of you guys know what microencapsulation is already? So does anyone know what micro means?
Small.
Exactly. Micro means very small. Does anyone know what encapsulation means? Encapsulation means putting one thing inside another thing. That's usually a capsule, where encapsulation comes from. So here's a video that Jeff made of the encapsulations that he did this summer.
If you just click it in the actual slideshow, then it'll pull right up.
But I can't see them all.
Great. So the second video, in this video, you can tell this is definitely micro because this is all taking place on the little 3x1 inch thing I showed you before. So this is little tubes inside of that, very, very tiny. So you can see that there's something surrounding something else, and that's exactly what encapsulation is. So these are some microencapsulations that I made. But what's the purpose of microencapsulation?
Okay, so microencapsulation is used to make cancer drugs less harmful to patients. And it's also used to make stem cells work better. And I'm going to explain both of those things in this next slide. So when it comes to cancer drugs, they have good and bad side effects. Obviously, they help cure cancer, but the bad side effects are that they don't understand. Cancer drugs don't know what cancer looks like. So they attack all kinds of cells that you put those drugs near. So that's why you hear about
the difference between these two sets of cells, normal cells and tumor cells? What's one difference?
More normal cells.
There's more normal cells. Maybe that's because they're smaller. Typically, tumor cells are a little bit bigger. What about the red spaces?
There's more red space.
More red space between tumor cells, and that's called intercellular space. Intercellular space is just space between cells. So if there's more space between tumor cells, that means that something bigger can fit between them. So cancer drugs, typical cancer drugs, fit right between normal or tumor cells because they're so tiny. But if we encapsulate those cancer drugs, then they can only fit between the tumor cells, and then they can't fit between the normal cells. And since they can't fit between the normal cells, they can't kill them. So all your normal cells stay alive.
Okay, so does anyone know what a normal cell is, like your human cell? A cell is just a biological worker that performs activities in your body. So your blood cells, they transport oxygen. Your immune cells, they'll like fight the bad guys. So Jack worked with stem cells. Does anyone know what stem cells are? Stem cells are cells that become any other type of cell. So here you see stem cells becoming muscle cells. They're becoming blood cells here, and they become neurons. So the good thing about stem cells is that, say you have a burn on your arm, we can actually put stem cells in that area, and that'll help your skin cells. It'll regenerate skin cells to help that go quicker. So does anyone know what the immune system is?
Helps you not be sick.
Helps you not be sick, exactly. It fights off bad germs and foreign things from your body to keep you healthy. But the bad thing about the immune system is it actually thinks some stem cells are the bad guys in your body, and it actually attacks them.
So microencapsulation gives stem cells a disguise from the immune system. So here we've got unencapsulated stem cells, and the immune system sees those and says, oh look, some stem cells, let's go kill them. And that's bad for you because then you don't have any more stem cells in your body, and those stem cells are actually helping you. But if you encapsulate your stem cells, then the immune system can't see them. And that means that the stem cells can stay in your body longer and help you more.
So this is a picture that shows successful encapsulation within Jack's lab. And what successful encapsulation is that everything's round and it's closed, there's no holes through it, so nothing can get in and out. And they're all about the same size, and you see that they're all about 200 microns, which is very small.
So the design process is pretty simple. You're going to have to replicate successful encapsulation. You're going to have to make an encapsulation around a marble so that it can survive a whole obstacle course. The trick with this obstacle course is it's going to have Velcro bits all through it that are symbols of the immune system trying to stop your marble from getting through, since your marble is also going to be covered in Velcro. So there's also going to be little grids like what you see here that your marble will have to get through or not get through based on where the grids are. So you'll have to optimize size so that only a marble of the perfect size encapsulation will be able to complete the obstacle course. The best possible outcome for this design process is that your marble will get the whole way through the obstacle course, won't stick to any Velcro, and will be able to avoid all the grids. Any questions?
Why can't the body see the microencapsulated stem cells?
There's a bit on all cells that they display that the immune system can recognize, but if that bit is on the inside of the big encapsulation, it's not visible to the body. So if they can't see that, they can't see the cells at all. Any other questions? All right, thank you.
Great job.
All right.